Okay, guys, we're going to have another calibration party. I know that you love keep watching these videos and keep talking about calibration curves on wit's end, right? 24/7. That's probably what you're experiencing right now, especially if you've waited to the last minute to do all of these assignments, and I hope that you've not. Okay, so we need to talk more about calibration curves. I know what you're thinking. How much more can we talk about it? Seems like we've already discussed everything that we need to know about calibration curves. Well, no, not really. All right. So what I want to do in this video is to give you, again, a little bit more detail as far as the calibration curve is concerned. So let's say that we make a calibration curve, and let's say that we plot standards on this graph. And hopefully it comes out to be something like a line, a best fit line right here. So it looks like it goes through the point 0, 0, which I said is very good because your blank should have close to a 0 absorbance or a 0 signal from the instrument or from whatever kind of method that you're following. And then up from that point, we get a linear regression line. So one of the things that you might see in a laboratory is this idea of a duplicate. All right. So what a duplicate is the idea of taking these standards and running them, but running each one of them twice. So that means if I make a 10 part per million, I will run it one time and then I will run it again. And then if I make a 20 part per million, I will run it one time and then I will run it again. And I will do that to each one of my standards. So all of a sudden, you're probably going to automatically think, oh dear God, I've got 5 standards and these people want me to run each one of them 2 times, which will give me 10 standards in total. Yeah, sometimes it is that strict in an analytical laboratory. Now, we need to step back and question why. You know, why would they want to do something like this in a lab? Why would a lab manager come around and say you need to inject these standards twice? One time is not good enough. Because it looks like if I injected them once and one of the points are not going to fit, then I should automatically pick that up in the regression line analysis and I could leave it out. Well, that's not the point here. The point of running duplicates is to really test your instrument precision. Right? So in a general chemistry class, we often talked about precision and accuracy. Accuracy is how close it gets to the bullseye in the center or your true answer, and precision is how close the darts are to each other when you throw them. So if precision hits the dartboard at the same spot every single time, we're good to go, right? That's called precision. Precision and accuracy has nothing to do with each other. So that basically means that I could be very precise in a lab and not get the correct number. In other words, I could throw my darts at the dartboard and they all would hit the same spot, but that spot is not the bullseye, right? So what happens when we run duplicates in a laboratory is that we have an instrument here and we're testing how good the instrument is picking up the data. So let's say that I run standard 10 part per million and I get a signal of 500 area on the instrument. Well, if I just leave it at that, I'm just going to understand that that was the first sample that was, or the first standard that was analyzed on the machine. This is a number that the machine reported. I'm just assuming that it's correct, and then I go to standard number 2. But with a duplicate, I could run the standard 10 part per million again. And what if I get 300 area this time? Which one's correct? Did the instrument have a fluke? Did the instrument just make a mistake, right? You've got to think there's all kinds of electronic pieces that are inside of these instruments that allow them to do their job. Well, what if one of those pieces, what if one of those valves, what if one of those pumps, what if one of those detectors that it's using to measure how much stuff is present malfunctions or has a glitch? These things can happen, right? Think about your computer. How many times have you randomly just got an error? You had to shut the computer down and restart it. Those things can happen in an instrumentation facility as well. Very commonly seen in an analytical laboratory. So for that reason, some laboratories will want you to do duplicates, and that's what we call those. Now, there could be duplicates of everything, right? There could be duplicates of what we call the standards, and that's why we do them. We want to test the machine and the reliability of the instrument. That's what we're after. We also can have duplicates of samples. So we'll randomly pull a couple of the samples and we'll do duplicates of those just to kind of do a quick check, a random spot check to make sure the instrument probably is functioning the right way. And we can also have duplicates of what we call the field samples. And those are the samples that we collect in the environment, right? If we go out to a source, whether that's soil, a lake, a stream, another company, a chemical manufacturing plant, and we collect samples out in the field and we transport those back to the laboratory. Sometimes we'll do those field sample duplicates as well, meaning that we'll collect 2 of the same type of sample. And we'll analyze both of those same types of samples in a laboratory just to make sure that the machine is telling me the right thing, right? So the field samples are really done to test the quality of the transportation and the storage of the samples. We want to make sure that all of those are okay. The samples, once they get to the lab, we might randomly pick one of those samples to do. And this just really tests technique most of the time for the lab technicians. And the standards are really for the instrument, really. You know, is it telling me the same story every single time? So maybe this is not going to cut it. Maybe when I run this duplicate for 10 part per million, this is not going to work out for me. So what is done? Well, we probably need to run it again a third time to see which one is it closer to, 500 or 300. If it's closer to the 500 a second time, then I could probably assume that this 300 was a fluke and it's not going to do a very good job. And if it happens over and over and over, then there's a problem with my instrument. I need to replace that instrument. I need to get a new one. I need to repair it. I need to perform some maintenance on it. I need to troubleshoot it. Something is going on with the piece of equipment. So very often you will see duplicates of standards that you will have to run. Some companies require you to do 2 or more of the standards as you run them to make the calibration curve. Other companies maybe will just want you to pick out one and just do one replicate. So you can have all 5 to be dupes, and you can have 1 to be a dupe, and you look at those areas or that signal just to check the instrument capability and performance. All right? So that's another insight of how we make calibration curves in the laboratory. Sometimes it's not just as simple as making 5 standards and running them and calling it a day, right? So this could be part of the quality control, quality assurance procedures that a laboratory company will require of you, and now you know a little bit more about it. All right, so in the next video, we're going to continue on with more specific details, kind of like this, tidbits of information that you need to take away as far as the calibration curve construction goes.